Okay, so we just learned what is the relation between the area and the integral. We saw that these are different things. Now I want to use those facts to evaluate integrals. So far, integrals were sums of some cumbersome, very complicated sums, in limit of some complicated sum. Now I want to use the area interpretation, or the relation between area and integral, and evaluate some integrals. Here, I have my function f of x is 3 minus x. What is the graph of 3 minus x? Oh, this is our friend. Well, this is minus x, but then there is plus 3. I will shift that. Let me see. I can shift this up 3 units. That's 3 minus x. Here is going to be 3. And then this is from 2. And this is 4. This is 5. Now, we are looking for integral of the function 3 minus x from 2 to 5. As you see, the regions between the graph of this function and x-axis, it has 2 parts, one here and one here. The small triangle is above x-axis. So above x-axis means that it will contribute to the integral with plus sign. With the other triangle, the bigger triangle is under the x-axis, so it will contribute to the integral by negative sign. So in other words, integral of 3 minus x from 2 to 5 is going to be area of this small triangle. What is this small triangle? It is, first of all, right triangle. Here's 2, here's 3. So the length of the base is 1. If I evaluate f at 2, this is going to be 1. Yes. So here is 1. So area of that minus the area of this bigger triangle, which is under the x-axis. Again, that is a right triangle. Here's 3, here's 5. That gives me base equal to 5. The length of this guy here is whatever f at 5 is, but not the negative sign of that. So here, f at 5 is going to be -2, but I'm just interested in the length of that guy. So I have to find area of that and subtract that from the area of the small triangle. Here, this is half of base times height minus half of, oh, who did write that? 5 there. It's 2. So 2 times the base. And while I evaluated the reevaluated the integral by using the area of some regions. Okay. The second one here, the function is this whole thing here, f of x. So if I consider f of x to be root 4 minus x minus 3 squared. Yeah. Here, what you need to notice is that, oh, I know that if I have y equal to 4 minus x squared, this is the graph of a semicircle of radius 2 centered at 0. So it will be something like this. This is 2. But then there is x minus 3. So that means that I will get my the graph of my function by shifting that semicircle 3 units to the right. So it will be, if we start from 1, I will go up, I will go down here at, well, I shifted everything 3 units, so this will go up to 5. The center, which was at the origin, and now we'll transfer to this 3 and 0. Okay, the radius is the same thing. So this means that what we have here is going to be the area of, by the way, this is positive function. So area and integral for the positive function and the interval are going to be the same thing. Area of semicircle of a radius 2 centered at 3 and 0. Well, the area doesn't matter where is the center. What matters here is that radius, which is 2. So area of a full circle is pi r squared, but we are interested only half of that. So this integral is 2 pi. And note that I didn't do any Riemann sum. I didn't do any limit. I didn't do any strange tricks. I just used the relation between the integral and area of the regions between the graph of a function and x-axis.